Okay, let's check out some trig equations with various techniques in solving these. So a couple things that you may want to look for is when you have tangents to convert to sines and cosines, right? Use the quotient identities. You might see double angles, you might see Pythag. Sometimes it comes down to just algebra, though, and factoring, right? Getting equal to 0, factoring, using the quadratic formula, whatever method that may come up. So many of these, it just takes practice. Some of these you may solve differently than someone else, and that's okay as long as the formulas are used correctly, the results should be the same. So here's how I would approach each of these. First one, I see two terms here, and they both have a tangent. I'm going to factor that tangent out and see what happens, right? So when I factor a tangent out, I still have 1 minus 2 sine x. Okay. Well, at this point, even though I have tangent and sine, right, two different trig functions, it's factored. I could set each factor equal to 0, the principle of zero products, and solve, and neither of those are too difficult to proceed. So where is tangent 0? Remember, tangent is y over x. So we don't want the undefined ones. Draw a quick little unit circle here. So y over x, if I had this point, right, that's 1, 0. 0 over 1 would yield 0. So that's a good one. And then this one, the same, right? I don't want these because y over x would yield undefined. So I don't want the ones on the y-axis. So this piece of the factor yields two solutions. We get x is 0 or we get x is pi. All right, now this one we need to go in and finish solving. We could say 1 equals 2 sine x, right? Add 2 sine x, divide 2. So where is sine 1/2? So sine, again, is positive, so quadrant 1 and 2. And where is it 1/2? It's the y. So we get this angle and this angle, which is 5 pi over 6 and pi over 6. I'm going to try to stay consistent here. Switch colors. So overall, we have 4 solutions, and you could check them. Okay, plug it back in if you're unsure. Make sure they work. But we have 4 solutions to this equation. We have 0, we have pi over 6. I'm going to try to go in order here. 5 pi over 6, and then we have pi. Alrighty, let's move down to the next one. Tangent squared equals -1 plus 2 tan of a negative x. Alright, first thing I would say, I don't like these negative angles. Sine and tangent are both odd functions, and cosine is even, so we get -2 tan x. Okay. Now, we're trying to solve for tangent, right? Think of a normal, like, algebraic function. If I'm trying to solve for x, if I had on the left like x squared equals -1 minus 2x, I'm trying to solve for x. It's a quadratic, right? I need it to equal 0. So therefore, same thing with tangent. Before solving this, like, I can't just divide tangent out. I want everything on the left-hand side. I'm going to add 2 tan, oops, I don't know why I wrote equal. Add the 2 tan x and add the 1. Right, just like this x squared, that's what we would do. And then I would factor. So again, you can use u substitution. Some of these, though, I think it's just easier to do it without. Like if you let u, in all of these, I shouldn't have been writing x, I probably should have been writing u. Let u be tan x, right? Then I would have u squared. Right here I'd have u squared plus 2u plus 1, and this factors to u plus 1, or u plus 1 squared, right? Either way. Well, I can still factor tangent. I'd have tangent x plus 1, tangent x plus 1, or tangent x plus 1 squared. Often I'll leave it like this rather than squaring it. That way I don't forget about any solutions here, but you can't factor and use zero product property without it equaling 0 anyways. So when you do square root both sides, even though you have to remember plus minus, right, square root of 0 is 0. So therefore we're only looking where tan x plus 1 equals 0, or tangent x equals -1. So where is tangent a -1? Tangent is negative in quadrants 2 and 4. Right, so, and I know tangent x is 1 is at a 45 degrees, so the -1, right, or pi over 4 is here and here. So those two angles are 3 pi over 4 and 7 pi over 4. Again, if you substituted that into the original equation, you should in fact see that tan x squared will equal the -1 plus 2 tan -x with both of those values. Okay, I'm not going to do the check in this video. I'll just say yes, it did work. All right. I wanted to include this next one because especially I see this happening with these problems, is trying to divide both sides by tan, let's say. So then you'd have tangent to the 4th equals 1. All right, you will get most solutions, but the problem is you may end up missing one of them. And one reason why is, like, again, let's just choose x squared equals x. Right? If I divided this x on both sides, I would just get x equals 1, right? But looking at that original problem, I know there's another solution. What about x is 0? So by dividing this x, we eliminated the solution that we in fact needed, right? We need to account for all possible solutions. And dividing one of those out could possibly eliminate one. And why does that happen? Because we can't divide by 0, right? So that's why that ends up being eliminated. So we don't want to do that. We still want to get it equal to 0. Subtract tan x, and then factor. So now in this factor here, right, tangent to the 4th equals 1, that is what would have happened, right? That's the 4 solutions we could possibly get if I had immediately divided the tangent out. But notice this one here, we also need to count where's tangent 0. So we could be missing a solution, or in this case with trig, I mean multiple solutions. All right, so the first two I already know from the first example. Where's tan 0? We get 0 or pi. Okay, there are 2 solutions to this right away. But tangent to the 4th equals 1. I'm going to actually, like, I don't want to do a 4th root here, and it will be okay, but let me just show you why I'm not going to do that. And it turns out it shouldn't change our results. But tangent, this is difference of squares, right? Tangent squared plus 1, tangent squared minus 1. Right? that's how I would factor a difference of squares. And then setting this equal to 0, we'd get tangent squared equals a -1. And then we'd get some imaginary answers. And for this, like, that doesn't yield any solutions, right? I don't know where tangent equals an imaginary. But for the right-hand side, I could factor again because we have difference of squares. Or remember when you solve and you take a square root to do plus or minus. But here I can't do square root of -1. I get an I, so we're done. Here I'm going to go ahead and factor again because I think difference of squares is important to keep in mind. So now we get where's tangent equal to -1, where's tangent equal to +1. So, or plus or -1, right? That is all of the 45-degree angles. That is all the pi/4 solutions. So now we will get a total here then of 6 solutions. We have, I'm going to try to go in order. Let's see, we have 0. Then we'll just use this one here. We have pi/4. We have 3 pi/4. Then we have that answer of pi. Then we have 5 pi/4 and 7 pi/4. Okay, total of 6 solutions for that. I think trying to compute just in our head the 5th powers where we would get the same results as the original, it's kind of tough, right? But breaking it down algebraically here, hopefully that ain't too bad. Alrighty. Last one. So there are no tangents here. Again, sometimes it's helpful to change it to sine and cosine, sometimes not. In this video we didn't, that's okay. But we have this double angle, and rather than thinking where's sine equal to cosine, we could do that, right? Where's sine equal to cosine? But then we have to think double the angle, and that's more challenging. Because I know sine and cosine, right, they're equal at those pi/4 spots. But this is double the angle of that angle, so I'd rather not. We have identities. We have a double angle formula. Sine of 2t is the same as sine 2 sine t cosine t. All right, now I wanted this one to kind of piggyback off that last one because a common mistake is dividing that cosine and just saying 2 sine t equals 1. But that's eliminating a possible answer. Try to get these to equal 0. Don't divide out a variable. Now we can factor out a cosine, and now it looks kind of similar to that very first one where we factored out a tangent, right? Factor out cosine. Okay, I wanted to end with this one as well because we've been doing a lot with the trig identities, and here's where we actually needed the double angle. So now we have where is cosine equal to 0, and then where is 2 sine t minus 1 equal to 0, or sine t equals 1/2. And then, so cosine is 0. Cosine is our x, right? So that's here and here. So that means t is pi/2 or 3 pi/2. And where's sine 1/2? That would be this angle and this angle, which we did in problem 1 as well. That's pi/6 and 5 pi/6. So now trying to get these in order, we have pi/6, pi/2, 5 pi/6, and 3 pi/2.